Thank you for the nice welcome and the opportunity to be here at the AI Day. So my name is Nelson. I work at Visual Meta, an international online shopping portal which operates in 13 countries, including Germany. And I work in the machine learning team. Basically, our responsibility in the team is to enrich our product catalog. In other words, to give every item as many labels or tags as applicable so that users on our online platforms can easily find items they are interested in. As part of this, we use machine learning, and hence the title Product Classification Pipeline at Visual Meta. All right. So the outline of the presentation is going to look as follows. I'm going to tell you a bit about what we mean by product classification at Visual Meta, and then tell you why we decided to use machine learning, and then walk through with you through the general pipeline that we use. All right. So when you visit our website in Germany, for example, ladenzeile.de, and you search, for example, for sneakers, you see a bunch of pretty looking sneakers of different colors, different brands, different materials, and so on. But actually behind this nice looking front end, what is there is actually a tag tree. Basically, we have a tree of tags, of labels, which is a very is a 7-level tree. Here you only see 3 levels, but it has 7 levels. And the tree starts with general tags like shoes and goes deeper. And as you go down the tree, you become more fine or more detailed. So you start with general tags like shoes, go down to like different types of shoes, sneakers, for example, different kind of sneakers, low sneakers, and so on until you reach down on the tree. So the tree becomes more detailed as you go through the tree. And the problem we're facing from the beginning is, how do we assign millions of items, as many tags as applicable from this tag tree that you see here? This is a very large scale problem because I only showed you on the tree few tags, but actually this tree has tens of thousands of tags. And in Germany, for example, we are talking about 60 million items from more than 600 partner shops. So basically, how do you map all these different items, tags, and partner shops to a single unified catalog? That was the problem we were dealing with at the beginning. One big challenge in this is that every shop has a different representation of their items. So basically, we are talking about 600 shops, each having a different representation for every item, right? And this is a very big challenge because you have to map all these different representation to a single representation, the tag tree I showed you previously. So in addition to the large scale, this way of having different representations is a big challenge. And from the beginning, there were 2 possible approaches. One was the manual rule-based approach, and the other one was the machine learning-based approach. The manual rule-based approach, because of this big challenge I just told you about, and also because of the scale of the problem, would have required very huge manual power, which we didn't have at the beginning. But also from the beginning, we wanted to be innovative, and so we decided to go for the machine learning-based approach. Actually, 10 years afterwards, today, the machine learning approach actually has proven to work so well that even if today we had the manual power to redo the same thing, we'll still go for the machine learning approach and use that manual power for some other creative and more innovative tasks. So this is just to show you how well this approach showed to be. In the next slides, I'm going to go through with you through the machine learning pipeline we use here at Visual Meta, which has different steps. I am going to focus only on 4 steps out of this, which are the machine learning based steps. So feature vector calculation, training, category classification, and sequential classification, which are the typical machine learning steps. The other steps I'm not going to talk much about, but they are also equally important. So for example, the sync, which is the first step, this is where we get items from our partner shops into our data stores. Blacklisting is a way of filtering items we don't want to show on our platform, for example, for legal reasons. And the monitoring and reporting is self-explanatory. So I'm going to start with some definitions so that we are all on the same page. When you talk about tags, by now you have already guessed, right? So tags are like labels which describe every product. So tags basically, in other words, are useful characteristics of items that users might be interested in. So for the first shoe, for example, it's a shoe, it's a sneaker, it is blue, it is of material canvas. All these are very useful characteristics, and all these form tags for us here. Another important definition is terms. Terms are keywords. Basically, with this machine learning approach, we needed to use keywords because we cannot use the whole text of an item, because the whole text of an item doesn't contain useful information. And QM, or quality manager, sat down and actually created a dictionary of keywords, or a dictionary of reference words, and we only use these keywords out of the text. So by getting the item on the left, for example, after applying stem matching or keyword extraction, we only end up with the box on the left. So out of all this text, it is only summarized by these keywords. And this is really nice because we have a way of actually summarizing every text that we get into the system. Thanks to QM, who have created this dictionary of, in Germany, more than 300,000 keywords. And after extracting these keywords on the left, we can go ahead and represent these keywords with numerical values, because one thing with machine learning algorithms is that they need a numerical representation. So how do we go from a textual representation on the left to a numerical representation? We use a very simple approach. Basically, we just counted how many times a keyword appears in the item. So this is really easy. If sneaker appears 10 times, the frequency is 10, and we multiply it by some weight, because depending on where the keyword appears, it has more or less importance. So for example, an item with sneaker in the name, we will consider that it has more weight than if this keyword sneaker was in the description, which is mostly more noisy from the partner shops. So this is how we go from a textual representation to a numerical representation. Is basically frequency, counting how many times a keyword appears in the text. And once we have a representation for every item on our platform, we go ahead and choose a machine learning model that we are going to use, or classifier as it is called. So basically, this is the algorithm which is going to use the representation we just got previously and train some model to be able to distinguish between different tags. We had a lot of models to choose from, and went for the simple ones. What was the reason why we chose to use simple models? Basically, the reason was because our dictionary was so rich that the complexity of the model didn't really matter here. So went for simple approaches simply. After getting these models, we needed to train the models. Machine learning is of course not magic learning. So obviously there are still some manual work involved. For example, in defining positive and negative samples. And it's out of these positive and negative samples that these machine learning algorithms are able to learn how to distinguish between, for example, sneaker and not sneakers. And this had to be defined by the quality managers. So once we have the representation, we have the model, and we train it using the manual negatives and positives provided by the quality managers, we can actually train models to distinguish every tag from the other tags. So to distinguish low sneakers from winter sneakers, or sneakers from ballerinas. So for every node on the tree, we train actually a machine learning model to tell us whether this is the tag or not the tag. And once we have this machine learning algorithms trained for every node of the tree, we can just throw in this tree all the items we get, and every classifier, every machine learning model will tell us whether the tag applies or not. So for the shoe here, the sneaker shoe we've been talking about, it's a shoe. it goes through the sneaker node, and the classifier is going to tell us whether it's a sneaker or not. It says it's a sneaker. It goes down under sneakers. We ask all the models of the types of sneakers, and low sneaker says yes, it's a low sneaker. Skater sneaker says yes, it's a skater sneaker, and we do this for all the items. And at the end, we are able to assign all applicable tags to all the items. One nice thing about machine learning is that it keeps improving, basically. So the more manual samples you add, the more the machine or the algorithm learns how to differentiate between sneaker and not sneaker. So it keeps improving as you add manual samples, and QM keep doing this, of course. The overall performance I was talking about at the beginning looks like this. So in Germany, you have an F score of 94. Basically, this means 9 of every 10 items that you want to classify are given the proper tags. And this is really a very good performance. And that's why I was saying from the beginning that this machine learning approach, because of the richness of our dictionary and also the simple approaches we use, we had such a good performance that actually it proved to be a very good idea to use this. As you can see, the performance is above 90%. Yeah. Thank you for listening, and I thank all the team members for contributing to the content of this slide and the PO for these pretty sexy slides. Now it's time for questions.